Yeah, thank you so much for the kind introduction, and also thank you so much for inviting me here. It's my first time in Estonia, even though I live in Denmark, so it's not too far away, but still, first time here. And yeah, it's really, really nice to be here. I have two sets of slides for you today. The one that should be showing on the screen right now is called An Introduction to NLP. So there I would give you a broad overview of things that are happening in NLP these days, also a bit of historical background. And then on Wednesday, we will do a deep dive into LLM, specifically their utilization of knowledge. So I don't know you very well. Hopefully, I'll get to know you a lot better through the course of this week. But specifically, I don't really know what you already know about natural language processing. So the first question I have for you is, what do you think natural language processing is? Maybe there are any guesses in here, or someone already knows?
Most people know.
Most people know, but they're still a bit shy this morning. Is that
ChatGPT, right?
ChatGPT? Yes. Well, yeah, that's what a lot of people think, and it is definitely a large component of it, but it's not all it is, and that's not how NLP as a field developed. So yeah, it's generally about building some systems that can understand and process and also generate language. And it's more than just surface level processing, it's about gaining a deep understanding of language. So it means the development of different tasks like question answering or machine translation, then the development of data sets for these tasks, and then also methods. Yeah, just to give you a hook on the right, you can see what happens when you ask ChatGPT what NLP is, and it comes with a list of different tasks. Not all of which are correct, by the way, but for example, it also says speech recognition, which is not a natural language processing task, strictly speaking, but is somehow adjacent. Okay, so why is natural language processing so hard? You might think it's not hard, but it is actually quite hard. And it is because there are ambiguities on all of these linguistic levels. And this is really going back to the basics. But if you think about natural language processing, people often think about it as this kind of pyramid where there are different levels of abstraction linguistically. You start from morphology, which is about how words are composed. And then syntax, which is about grammar. Semantics, which is about meaning. And then pragmatics, which is about meaning in context. And people often get confused about the pragmatics bit. So as an example, I could say, well, what I said earlier about, I'm going to talk about introduction to NLP now, and I was trying to say these are the wrong slides, but I didn't say it explicitly, and then I had to say it explicitly for the meaning to come across. But that would be an example of pragmatics, where there was an implied meaning, please put on the different slide deck. Or I could say, it's a bit cold in here, and maybe there's a window open, and that could mean, someone please close the window. Right. And the difficulty is that there are ambiguities on all linguistic levels, meaning that there are different ways of reading the different sentences or words or such. And a very traditional example in linguistics are garden path sentences. Could you raise your hand if you've heard of garden path sentences? One person. Okay, so it's more of a computer science crowd then. Let's take the last one maybe as an example. So it says, the old man the boat. So when you originally read this, you might think you have the noun phrase the old man and then another phrase the boat, and then your brain gets really confused and thinks what's going on here, because there's a verb that's missing and such. So where's the verb? Well, actually, the verb is man, to man. And it's not a very commonly used verb, but it does exist. And you can see similar things in all of these sentences. You can see on that slide. And yeah, this is a typical example of why things are difficult for humans to understand, and that also makes it difficult for models to understand. Though at this point, LLMs have memorized all of these garden path sentences, so it's maybe less of a problem these days. But still, for new sentences, it would be an issue. Okay, but all of these ambiguities have downstream implications on tasks, such as question answering, or here, machine translation, because then for a given sentence there can be different translations. And how do you know which one to pick? That's quite difficult. So yeah, another one from the middle here that's quite common is Jane saw the man with a telescope. So then it's unclear if she saw the man holding a telescope or if she saw the man through a telescope, for example. Yes. Okay, so now a very brief history of NLP, and it's, let's see. Okay, so the beginnings were pre-1950s. So let's do a quick test again. How many of you have heard of the Turing test? Okay, so I don't have to talk about that. That's good. Okay, so pre-1950s is when it all sort of kicked off. There was information theory was introduced as a concept, the Turing test, but then also closer to natural language processing, there was this memorandum on translation, which was talking about how to automate a translation, and those were really the beginnings then of natural language processing methods. And then between the 1950s and 1990s, it developed quite slowly, and people started to come up with some rule-based methods. There were lots of developments in linguistics, for example, the Chomsky hierarchy, and then also developments in parallel on the machine learning side, for example, of hidden Markov models, which were quite commonly used models back in the days. And then also the first larger data sets, so for example the Brown corpus, which was used to train models. Syntactic and semantic parsing were some of the first applications then as well. Things developed very slowly there. There wasn't so much funding back then. But in the late 1990s, especially the US government realized, oh, machine translation, this is something that we can really get to work, and there might be some real applications in this. So there were more grants in that time, and during that time, and people worked on machine translation. They also worked on dependency parsing, which is transforming sentences into grammatical structures to then feed into machine translation again. And at this point, many different kinds of machine learning methods were explored. This was quite an interesting era for NLP research, because there was quite a bit of diversity, I would say. There wasn't just the one machine learning method, you have to use it for everything, but people were really experimenting with support vector machines, logistic regression, conditional random fields, and so on, and what different features would work and such. And then after this era, people found out that deep learning actually works really well for natural language processing too. And then the first we could see if this was Word2Vec, word embeddings. Hands up again, who's heard of Word2Vec? Okay, so this is something you're familiar with, good. Okay, perfect. And then based on word embeddings, people developed RNN-based approaches. And this was quite an innovation which led up to LLMs too, is sentence embeddings, reusable sentence embeddings, whereas prior to that, people had to train them on and construct features on the fly. For every single application then. Yeah, and this then led to large language models as we can see them today from 2020 onwards. All the different kinds of variants. I'll have a specific slide on that, so I'll not go into too much detail here. Okay, so recent methodological developments is what I'll go into now, specifically some of the details around large language models. but not too many, because I know you're a relatively diverse audience, and also there's quite a bit of ground to cover still. Okay, so recent methodological developments, I talk about language models, about how they work, how to get them to work with in-context learning and human preference alignment. Then I'll mention some recent tasks and challenges that still exist, even with LLMs today. And then outlook and open topics, because I know that some of you are doing a master's and might be thinking about a PhD, and might be thinking about what kind of work is there even left for me to do. So I'll also talk a little bit about that. Okay, language models. When language models were released, it came as quite a big surprise to society at large, not so much to natural language processing researchers, because this had been in the works for a while, but people were really surprised, and it was the first time we could really see some massive public uptake of NLP technology, even though Google Translate and such already existed. But yeah, people used it for everything, to write poems, for example. Also applications like merging dictionaries, looking for investment advice, and all of this meant that ChatGPT very, very quickly became a very widely used application then. And when is that from? December 2023. It stalled a bit there, so let me check again. March 2023 was really the height of this, and it had, roughly almost up to the number of users as Amazon and such. So this is quite nice, and quite impressive. But how does it actually work? So again, let's go into some of the details here. So language models under the hood just calculate the probability of seeing a sequence of words. And large language models are a type of language model. So when you have a beginning of a sentence, I saw A, you can calculate the probability of that, and based on that, calculate the next most likely word. For example, it could be cat, and then afterwards it could be mat. And then if you have a full sequence, you can compare sequences against one another too. You can compare different kinds of completions. So you can calculate, is I saw a cat on a mat more likely than I saw a cat outside my house. And this kind of sampling, it works iteratively, one word at a time. That's the basics of it. And early applications of this were, of course, sentence completion, and then it's was also used for suggesting different terms for search. Now, as said, LLMs have their beginnings in language models, so they were not invented by OpenAI, but back in the days in the 1980s, and they're based on n-gram language models. So where they're not modeled using neural networks, but they were modeled using lexical features, and based on truncating the history of the sentence to an n-gram, which can be 2 or 3 or more different tokens, and then calculating the probabilities of that, and based on that, calculating the probabilities of the next most likely continuation, to sum it up. Then there were neural language models in 2000. Then we had transformer-based models in 2017, of course. And we had, in 2018, we had BERT, just to make sure you're not asleep yet. Who has heard of BERT? Okay, excellent. Right, and then based on that, prompt-based learning emerged. So there was GPT-3 and Instruct GPT, and then based on that, conversational interfaces like ChatGPT were finally released. And if you want to know how the initial ChatGPT works, then your best bet is to read the Instruct GPT tech report, because you can't find one for ChatGPT. Just as a side note. Okay. So now there are many different things I could talk about in the rest of this lecture, and this is just the overview of the chapters of fundamental algorithms from the famous book on the speech and language processing by Jarafsky and Martin, which is commonly used to teach NLP. But I will just go into large language models and then into different ways of using them. But this really isn't to say that that is all there is to NLP. It isn't, but I just don't have time today. And I figured this is the thing that you're most interested in hearing about anyway. All right. So how does this all work? Well, standard supervised learning, to take a point of departure, it requires some weight updates based on gradients, which are computed with respect to loss function, which I assume, given on your raising of hands, you probably know about already. So you have some kind of training set, for example, for sentiment analysis, and you have some kind of test set, and then for each of the instances in the training set, you have a label, for example, 0, 1, and then for the test set, it's unknown. You have some kind of input, which is run through an encoder. There's some kind of classification head, and then you predict 0, 1. Yeah, and this is just an illustration of how this looks like with the, and then iteratively you adjust the weights of the model. All right, so the difference with in-context learning is it doesn't require any weight updates, it doesn't require any gradients, and it also doesn't require any loss functions. One might even say it's not even learning in that kind of sense because there are no updates, so it's really quite different. So it's really just interpreting input on the fly at decoding time. And the data samples are passed directly as input to the model using a frozen large language model. So the parameters of the model are not changed. So you might have delicious food, sentiment positive, the food is awful, sentiment negative, and so on and so on. Then you have a review saying good meal, sentiment, and then the model is supposed to complete that. So again, underneath the hood, this is all just language modeling, autoregressive language modeling, which is trained on raw text with the next token objective, so exactly like traditional language models. And using self-attention with the transformer architecture. Yes, and the context helps the models to understand what should come next. If there is no context, then the models will have to guess a lot. So it's really that context based on which the predictions are made. Okay, so yes. And then there are many different input templates which can be used to make this prediction, to use language models for essentially, as one would previously use supervised learning. So you need these different kinds of verbalizers, and verbalizers are ways of turning 0, 1 into words, so you can have positive, negative, yes, no, or such, and that's done manually when you provide some context, some kind of history. And this is what most of you will be familiar with too if you play around with language models, that you need to have some kind of good way of finding verbalizers and some good way of phrasing the task, because otherwise you might not get the answer that you want. But language models are getting increasingly better at that because they have seen different variants of this, but more about that in a second. Yeah, and then you can get some outputs which can then be generated and parsed. But language models don't always cooperate with this. So if you give examples with positive and negative, then what you mean to say is that the model should generate answers with this positive, negative too. But the model does not have to cooperate. It can also just say, it's the best one I ever had. Right? There's nothing to force it to do that, because the decoding is just completely free. It's not constrained decoding, which was what was previously which is what can also be used. Okay. Yeah, you can also have some kind of class ranking, of course, if which is just the probability of these different scores. If you have a model that you can actually access, it's not always possible for API-based models. Okay. And yeah, you can also use them for grammatical error correction or other kind of text generation tasks like that. And the core advantages of the previous way of doing things is that one model can now be used for many different tasks. So it can be used for sentiment analysis, abuse detection, and so on. And the reason this is good is because then we don't have to fine-tune these models. That was what people spent a lot of effort doing previously, fine-tuning these different models. And now the models can just do all of that out of the box. And there have been many different pre-trained models that have been released and are still being released. And often they're available using API only, and they're getting bigger and bigger. So it takes a lot of hardware and a lot of energy to train them. And the bigger they get, the less feasible it is to actually run them somewhere yourself. Okay. And yeah, the other thing is we don't need a lot of examples. So previously one would have to hand label a lot of examples or find a suitable data set. But here it just works with a handful of examples which you can quickly create yourself. Yeah, often it, oh sorry, did this work? Yeah, it also works without any examples. You can also provide a direct instruction to the model, for example, correct the grammar of the sentence, I loves my new watch, and it will correct it to I love my new watch. Or translate something to French, or determine the sentiment of a sentence. Now, if you want to know how this works, I said going to the Instruct GPT tech report is a good way of doing that. And also the open source language models, they often come with, there are some open source language models these days which come with papers, so then you can also read about it in more detail. But this is still about the beginnings of how ChatGPT works, and it's from the website. An example here of you can have different kinds of in context, different kinds of shots. So you can have one shot or few shot, which is the number of examples that is provided to make it work. Yes. Okay. And yeah, what they found is that just having very few shots, so maybe 3, really massively improves performance over having no examples, and it very quickly gets up to having a fine-tuned previous model, the BERT model. And this is from 2020, so you can imagine, or you probably know, that many models now outperform humans on various tasks. Okay, but now I've talked a bit about how to train vanilla language models. Now there is actually one bit that's missing that I haven't talked about, which is how to turn these language models into chatbots. Because out of the box, language models are good at generating text, but they're not yet good at communicating and following human instructions. So given a question that the model doesn't really know what to do, should it answer the question, should it reformulate it? It's not really clear. And that requires human preference alignment. And there are 2 common methods for this. One is called reinforcement learning with human feedback, and then there is direct preference optimization. And there are many more these days. But for both of them, the core of it, and for more recent ones too, the core of it is that you need some kind of human preference data, and you collect that by first having a task. For example, write me a poem about the history of jazz. and you have different poems, and you present pairs of those to users, and you ask them which one they prefer given the prompt, and then based on that, the models are fine-tuned using either reinforcement learning or direct maximum likelihood estimation. Okay, so this was the background on just recent methodological developments. Now, I would go over to recent tasks and challenges, but before I do so, I wanted to make sure that there weren't any burning questions about this part. Yes, at the back. Right, so the question was, LLMs, they work really well for English and they're developed for English. Is there another language that works well besides that? And maybe also a little bit of why this is happening, maybe. So yeah, the problem with natural language processing is such as that it's always been an English first type of field. So people develop methods for English first, and then they develop methods for other languages. Now with LLMs, I'll show a slide regarding that later on as well. Especially for Chinese, there are other models, and there's a lot of money being put into making this work. So Chinese is definitely the language for which LLMs work second best, and maybe not the same LLMs, but other LLMs specifically for Chinese. So there are different factors that play into this. I have it on some other slide later on, but yeah, there is, of course, the amount of data that you have. There is how big the models are, how much you train them, and then the architecture itself, of course. And for Chinese, it works well because there's a lot of commercial interest in making it work well. So there is investments in it to train these big models, but also there are many. Chinese is a really big language community, so there are many speakers of the language, and there is a lot of text to train these models on. Whereas for smaller languages, there isn't so much text, and that's really one of the bottlenecks. When you don't have so much text, then there's so much you can iterate over, and then for a Danish language model initiative, for example, people train on English first and synthetic Danish, and then on real Danish, and that's sort of how you can mitigate some of it, and you can squeeze out some more performance points. And beyond that, you would just have to collect more text, and that's really expensive. Yeah. Are there any other burning questions about the fundamentals? At the back, yeah. That's a really good question. So it was about, does Chinese require less data than English? It's not a field I follow or a direction I follow very closely, so I couldn't say. My guess would be that it doesn't require less data, but I really couldn't say. I'm sure that people are looking into it. With LLMs specifically, one of the issues is that a lot of research happens behind closed doors, especially when it comes to what data goes into these models. So when it comes to how to really squeeze out the last bits of performance gains, there's a lot that I don't know just because it's not been documented. And when we do research in academia, it's often on smaller language models, and we can try to estimate some of these trends too, but then, yeah, we don't always get the full picture. Yeah. Any other questions before I continue? Yeah?
Thank you. While you were explaining my question back then, you used two phrase that's very interesting to me. You use synthetic Danish and real Danish. I don't understand. Is it some kind of NLP term, or it is some kind of linguistic term? I'm a little bit confused about that. What is the synthetic Danish and real Danish?
Fair enough. Okay, so synthetic Danish isn't a new language, but it just means you use a language model to generate more text, which is synthetically generated, so automatically generated, and not manually generated. And so it's somewhat resembles how people would write, of course, in the same way that LLMs resemble how we would write, but there can be mistakes, and it will also overemphasize some aspects. Yeah, and people have argued that these kinds of approaches can over time lead to model collapse, where models are just trained on more and more synthetic data, and at some point they will stop working. But yeah, it's in the short term, it's the best way of squeezing out some more performance points still, because it's cheaper than asking people to actually write more text. Okay, then I will continue. But yeah, I would really like you to ask some more questions later on as well, because I've planned for about half an hour of discussion. So if you don't ask any questions later, then I'll be done with this lecture much more quickly than I've planned, which is also fine, but I'm sure you have many things you want to know as well. Okay, so in terms of recent tasks and challenges, given how well large language models are performing, one could ask, are we seeing the emergence of artificial general intelligence? And I know many people have many opinions on this, but one answer to this could be no, the other being yes. But the reason I say no here is because in various evaluation studies that have been done, we see that there are still many things that language models can't do, where they can't perform as well as humans and fail at some fundamental capabilities. And another kind of meta comment regarding this is that it's really hard to benchmark language models, because language models have been trained on most of the benchmarks. So if you have a data set that's available online, the LLM will have been trained on it unless it's password protected. But as soon as it's online, an LLM will have been trained on it. And this means that this is called dataset contamination. So because LLMs have already seen the answers to the questions or the translations of the sentences, asking them to make these predictions isn't about them being able to abstract and to reason and so on, but it's just about them being able to recall the answers, which is not the same thing as reasoning, and it's not the same thing as artificial general intelligence. And yeah, this phenomenon, it's quite troubling, because we don't really know how to go about it. People have worked on measuring it now, but yeah, it's difficult to stop it from happening. And yeah, actually, even talking to people who work on developing LLMs, they are worried about this, because they do want to measure the performance, but then how do you actually design new test sets and such? Okay, and then one thing that's already been mentioned is there's this issue of multilinguality. So language models have poor performance on low and on very low resource languages. They work well on English and Chinese. I can only assume that they do not work so well on Estonian. I've not tried it myself, but the more low resource you go, like Sami languages or so on, the more hopeless it becomes, because they really do require a lot of training data. And then in terms of reasoning, they don't perform so well at multi-hop spatial mathematical reasoning, but are okay at temporal reasoning. And of course, the capabilities are improving day to day. So this is from an evaluation study in 2023. But yeah, the other thing is that there are what has been termed hallucinations, which is factual statements that cannot be verified from its source, from its parametric memory across tasks, since it doesn't possess, the language model does not possess access to an external knowledge base. And just to say this term parametric memory, so this is the internal memory that language models have. Yes, well, when ChatGPT was released, one of the first things my PhD students, of course, was to ask them about their professor. So they really wanted to know, what does ChatGPT know about me? And this was the result here. So I'm not going to go into the details here. And this is not the most recent version of ChatGPT. People always ask me that. But I am not redoing this slide for every lecture I give. So the color coding takes some time. But yeah, so you can see the green bits are correct, the red bits are incorrect, and the orange bit is sort of up for debate. So it gets my PhD award age wrong, my title wrong, then some award I won wrong, and also something about an editorial board. And then what area of work I'm really known for, it says sentiment analysis and name entity recognition. I would disagree with that, but nah, maybe it's okay. It's close enough, I guess. But yeah, one thing I find quite interesting about this is that this award that it says I've won, it's called Google Faculty Research Award, and they say I've won it in 2020. The award does exist. I was never awarded this. And it wasn't awarded to anyone in 2020 because the program was discontinued in 2019. So there are several things that got wrong there. It was a prediction, yeah. Yeah, maybe. All right. So this is just an illustration of hallucinations, and you can. There are many funny ones out there too. You can try it for yourself. Yeah, so there are many different factuality challenges, and I will go into some of them. So there is truthfulness, which I already mentioned, lack of credible sourcing. Again, LLMs are getting better at this with every generation, but still, sometimes you still find links that don't actually point to anything, or links that don't point to a credible source, but just to some source that was highly ranked. Still, confident tone is a challenge because it can often mask that something is incorrect. The same goes for fluent style. Direct usage of misinformation. So as soon as something is online, LLMs will be trained on it, whether it's true or not, unless there's some very good data filtering, which, yeah, there isn't so much, at least. I'll show examples of that later. Then ease of access, everyone can use them. The halo effect, that LLMs perform well on some things, not so well on other things, but that means that they're seen as being a credible source for many different domains of knowledge, and yeah, also different in different languages and so forth. Also, they're perceived as being a knowledge base, even though they're not. Language models aren't knowledge bases, but they're being used as knowledge bases these days, and they, when you interact with them, they somehow mimic knowledge bases, but still they're models that predict the next most likely word, which is a slight difference. And then, as I mentioned, the evaluation is unreliable. Okay, so I will dig deeper into some of these aspects now. I have something about persuasive language. So we've done some research on this, where we measured LLM's capacity to generate persuasive language, and also factors that influence how persuasive that language is by comparing different text pairs and measuring if they are marginally, moderately, heavily, more or less persuasive, given a human written text and then an LLM generated text. These are just the base results of what happens when you prompt language models, different kinds, to provide more or less persuasive text. And you can see the lightly colored ones are when you say it should provide more persuasive text. And at the bottom, the -3 is indicates that the text is most. That's on the far scale of the persuasiveness, and then 3 is much less persuasive. And you can see if you prompt them to be more persuasive, they actually are more persuasive. If you prompt them to be less persuasive, they are actually less persuasive. So that works. But what if you give them personas? So a persona is to say, for example, you are a journalist for a scientific magazine, you are a journalist for a tabloid magazine, or you are an extremely right-wing, or left-wing politician. And this actually changes persuasiveness, even though it's not part of the prompt. But just by giving the LLMs a persona, it will adapt to what it thinks this kind of persona would write like. So you can see here if it has the tabloid persona, and you prompt it to generate. Let me see. Okay, maybe I don't try with the pointer, but you can see that if you say it should be more persuasive, it is more persuasive. But even when you prompt it to be neutral, so not change the persuasiveness, it ends up being more persuasive, right? And the same thing goes for right-wing personas. And this is maybe an unintended side effect, so you should really be quite careful about that. And then another thing which you might have heard about is sycophancy. How many people, who has heard of that? Yes, a few of you. Okay, so this is really the phenomenon that LLMs, they aim to please. So if you provide them with some kinds of a prompt saying, I like this, I don't like this, or so on, it will adjust things accordingly. So here you have, please comment briefly on the following argument. And the answer of that will be different to, please comment briefly on the following argument, I really dislike the argument, or I really like the argument. So on the right, you could have this chart which shows the positivity, and you can see that when it says I really dislike the argument, then the response is much more negative than if you say I really like the argument, then the response is quite positive. Now there are different kinds of this, different ways of swaying these LLMs. So there is the saying, are you sure? And just by saying, are you sure? It quite often says, oh, I apologize for the error. And you have something here about which country was the largest producer of rice in 2020. And you can say, I don't think that's right, are you sure? And I will say, I apologize for the error. But when people first documented this, quite a common example was to say, well, what is 2 + 2? And it would say 4, and then you would say, no, it's not 4, it's 5. And then the LLM would say, I apologize, it's 5. So it's really troubling, and it really illustrates that LLMs are not knowledge bases. They are just, that they are something else. They mimic, maybe they have the appearance of it, but they are language models. So what else do we have here? So yeah, this is that AI assistants can conform to user beliefs. So here is an example where the assistant first says hydrogen, and then the human says, I do not think the answer, I think the answer is nitrogen, and again it's corrected. and then this is an example of an LLM mimicking user mistakes, which can happen if a mistake is part of the of the context that's provided. So here the human says, "I love this poem by the poet Sylvia Plath," and it was actually written by a different poet. Okay, so yeah, then the question could be, how does this all emerge? When does this actually happen? And looking at some different features, often the LLMs just try to match user beliefs. Okay, so this kind of phenomenon is quite consistent across different tasks and different language models. Well, humans prefer responses that match their views, so often they will be happy about that. Humans and LLMs also prefer convincingly sounding responses over correct ones, is what this paper also shows, which is quite troubling too. So yeah, given what I've just presented, does anyone have a guess for why this is happening? Or maybe knows it? Yeah. Yes, so this is a very good point. So the answer was that this is actually how LLMs should work, and this is one view to have, definitely, and this is also the reason why they work this way. So LLMs are trained to adopt to human preferences. They're trained with this human preference alignment, and that means they are trained to please humans. They are trained to do what humans want, and if humans say no, this is incorrect, then of course this is what they will do. It's a general part of the behavior of AI systems, just because of the way they are trained, and that means they can sacrifice truthfulness in favor of this kind of behavior. And in the talk on Wednesday, I will go a bit more into what are LLMs really, and the different things they're used for. They're not always used for this truthfulness, but people are increasingly using them as knowledge bases, and big companies, they're also encouraging that by incorporating it as part of search, and then having the AI summary and so on as part of that. Yeah.
Same that Marlon said, but in your answer I find it a bit frightening that you also repeat this, the people want. I mean, who knows what the people want? It's just what the big companies who produce these models think that people want, right? It's a bit like these marketing people that say, well, customer's king, but in reality it's only like maybe 70 or 80% of the customers. So what? I mean, as a researcher, I find this quite difficult to handle this problem, right? Because I'm sure that there are many people who do not want that an LLM works as it works. So how could that be taken under consideration or influenced by researchers?
Yeah, I mean, I also don't want an LLM to work the way it works, but not much I can do about that. What I mean by saying what people want is that when they are fine-tuned to these preferences, then part of this preference alignment is really aligning it to human what human state they want, and this fine-tuning process leads to this kind of behavior. So it's not what individual humans want, but it's part of how they are trained. Is what I meant. But yeah, individual humans want different things, of course, when they use LLMs, and this is quite difficult, and LLMs are seen as a one model for everything, and the question is, should there really be one model for everything, or maybe not? And I'll have some points about that later on as well. Yes, one more question, then I'll continue for a bit.
I think in a way pleasing humans is fine. I mean, I would like to be pleased, and it's just that I want maybe as the first thing to say, don't hallucinate in the system prompt. No, if that would work and the model would be able to please me, that would be great. The problem is that even if I say don't hallucinate, it still hallucinates. So there are, I guess, remaining challenges in that regard. Maybe just that was more of a comment, but brief question, like just to get your feeling about hallucinations. Do you think would it be likely that let's say in a year or two these things would be figured out how to get rid of, or is it very unlikely to happen?
It depends on what you mean by figure out, but this problem of hallucinations is it's just part of how LLMs work. So it's not something we can just figure out. We can reduce it, but to really address it, we need a different kind of model paradigm, which at the moment when we look at alternative model paradigms, they have different downsides. So there's the there's the option to take a symbolic approach where we use actual symbolic knowledge bases, and those have many downsides. People have worked on combining them with neural networks and so on. This is the only real alternative to it currently to reduce hallucinations, but it has many other different downsides, and currently there isn't anything that fully somehow resolves that, but there are some hybrid approaches still that do overcome it, but yeah, not any that are widely used, at least. Okay, but let me continue then. So another thing which I already mentioned earlier is that LLMs are sometimes trained on incorrect information online. And this leads to some really scary phenomena, including what's called LLM grooming. The term already sounds a bit uncomfortable, and yes, it is because there's a reason for that. So there are certain countries, including specifically Russia, which have disinformation networks, and they're specifically attacking LLMs with this kind of disinformation by publishing lots of propaganda at scale. And this is a known phenomenon that's been documented by journalists too. And they have this disinformation network, publish many articles in different kind of countries, different languages across different domains. And the scary thing is it really works. So this is from a study done by a journalist here. You can see on the, they just tried different kinds of common disinformation narratives. And you can see on the left to what degree they succeeded. So it depends a bit on the language model, but it's up to something like 60%, the success rate of if the LLMs have been trained on this kind of information. And this is not knowing if they've. This is testing if they can replicate it and if they can use it as part of something else. But this isn't actually knowing if they've been trained on it. So this is probably an underestimation of the real phenomenon. Okay, then one common way in which people try to address factuality issues is by somehow combining language modeling with information retrieval, where you have the real information somehow, or the factually correct information in some other document, that's the assumption, and then you work it back into the generation. And yeah, the way this works is you have the normal kind of prompt, And then you retrieve some kind of documents based on that. In the vanilla sense, you maybe chunk them and recombine them and so on, and provide them as context for the LLM, meaning you just add it to the prompt and then generates an answer based on that. And there are many different ways of improving on that. So yeah, people don't usually look at the intersection between the language model and the retrieval model, but they do work on the two different parts independently. So looking at how things can be done pre-retrieval, or how things can be ranked or re-ranked afterwards. But then this already improves the performance a bit and makes LLMs more factually correct. The other thing is to say you just use the generate text as is, and then you automatically correct it. And that's some of the things we've worked on too, on fact-checking of machine-generated misinformation, where you then really split the sentences, contextualize them. You try to see what should be checked. You then retrieve some evidence. You identify what can or should be corrected, you edit it, you merge it again, and you have a corrected version afterwards. This is much more involved, of course, than just retrieval augmented generation. But yeah, when we tested that, it did outperform it. So yes. Then another phenomenon which many of you will likely know, and it's called prompt instability, meaning that depending on what kind of prompt you use, you will get a different answer. So this here is on a task about homophones. So pick out the words that sound the same. We ate the number and ate the verb and mouth. So pick out the one that sounds different is, I guess, the question. And then there are different ways of formulating this task, and depending on which formulation used, you will get the right answer or not. And this is also a thing that's really been an issue with LLMs, and LLMs are getting better and better at it because they're trained on more and more different prompt variations. But if they've not seen the prompt, they're likely to not perform well on the prompt. And this is another way of really realizing they are not knowledge bases. They do not really understand what humans write. They just remember how to follow the pattern and can then predict the next most likely word. Yeah. And some common approaches to this are automatic prompt tuning based on some labeled data sets. Using reinforcement learning, where you test different prompts, you test what prompts perform well on some known text classification data sets, and then you rank them and combine them and so on. Another one which you might have heard about is called chain of thought prompting. So the idea there is that you break the task down, and by breaking it down, the model performs better at it. And you also prompt the model to, or the model also produces some kind of explanation of how it arrived at the answer then. And you can see the thing on the blue text is what the model has additionally been provided with, which is a breakdown of how the task should be done for another example. And then it can replicate that for a new kind of example. Yeah, so this is one thing that can work. Another thing that people are working on to try to identify when models don't perform well, but also try to work out how to correct them then, are different approaches within interpretability. And I will go a lot more into this in the lecture on Wednesday. But yeah, just to say, there are different kinds of streams of that. There is the global analysis, where you look into the model holistically, try to work out what's wrong, how can you edit it. And there are some local methods where you look into it for specific instances. Many different kinds of methods. One stream of methods is called attribution methods. and this I will go into more on Wednesday, which is about trying to understand for individual instances, for individual sentences, for example, what kinds of neurons can you trace the answer back to, or what instances. Then another issue with LLMs that you will likely have heard about are social biases. And that's based on the text also that the models are trained on, based on the text, but also partly as a result of the human preference alignment, really based on different things. And then there are efforts, including work that we've done on trying to benchmark these biases. And as I said earlier, the benchmark is available online, so LLMs will have already been trained on it by now. But yeah, when we did it, we came up with this benchmark, and we got results for different language models on different kinds of biases, including gender, religion, what else do we have? Nationality and disability. Yeah. Then LLMs also have political biases. That's another thing that's known, and again, it's something that you can benchmark. Generally, LLMs tend to be more left-leaning, is known, and as I mentioned earlier, you can also give LLMs a kind of persona, and depending on what kind of persona you assign it, it will be more or less left or right-leaning, or display different kinds of result in different kinds of answers. And there's different work on debiasing language models. You can do supervised fine-tuning. Using some examples, you can try to do unlearning. Then you can use an interpretability-based method where you go and you try to edit some neurons. But actually, most of the best performing methods still are prompting based. So that's actually a good thing in the sense that it can be done quite easily. So just by firing a prompt and saying, please debias it, or some kind of variant of that, it will already be less biased. But it also means there's still a lot of work that can be done on creating less biased language models. Yes. Then, oh, sorry, did I skip something? No, okay. Then something that's also increasingly gaining traction is making LLMs more culturally sensitive, because they don't always generate answers that are in line with the different cultures they're supposed to represent. So they just focus on the majority culture that they are trained on. And we've done a survey where we looked into different kinds of culture data sets, what there is, and also different methods. And you can find more in the survey paper. But some of them are manually constructed, some of them are automatically constructed. Often they're adapted from existing data sets. But it is quite difficult to collect that data, especially for minority cultures. Most of the research focuses on high-resource languages, and specifically English, as I said earlier, also Chinese. And low-resource languages and regions, especially in Africa and Latin America, are underrepresented. And another thing that's getting increasing attention is even the work that then focuses on better representing culture, focuses on countries' boundaries as the boundaries of culture, whereas especially the larger countries, they represent, there are so many different subcultures, and the subcultures cannot always be represented in this geographic manner. Then we also have vision language models, which is another recent trend. For example, CLIP was one of the early ones, and there'll be more. You'll hear more about vision language models, I believe, tomorrow, so I won't say too much about that. but essentially the early ones were sort of combinations of language encoders and then image encoders. And yeah, some of the work in Copenhagen too looked at this intersection of vision language models and culture, trying to get more diverse representations of what, for example, people playing ball can look like in different cultures. I think this is from basketball, and you can see that some people played inside, some people played outside, and so on. And unless the model has some diverse representations of that, if it's only trained on images showing that basketball is trained inside, it will find it difficult to recognize when it's shown images of basketball being played outside, and when you try to use it to generate images for playing basketball, it will only generate these kinds of images. Just to give an example. Yeah, and again, you will hear much more about this, but vision language models have a long way to go. Here are some funny examples. So on the left you have prompting DALL-E 3 for the ingredients to make a cake. And you can see on the surface it looks like, well, this is maybe looks roughly like what it should be, but then you can look at the labels, and there are some really funny ones. So some of the sugar is labeled as sugar, but then you also have budger, wedge, then you have an egg labeled as milk, and podper is some flour on the surface, and so on. So yeah, this is one. And then here another common thing is that when they used to generate images containing text too, then the text is often complete nonsense. So here you have something about, you can see coffee, spib, kliop, and so on. It's just random gibberish. So yeah. Okay. So this was it on some of the ongoing things. Now I have some more slides on Outlook and open topics, and then there'll be some time for discussion at the end still. So Outlook and open topics. So hopefully I convinced you, or you were already convinced perhaps, that while LLMs perform really well, they're not the be-all and end-all of natural language processing or of research. There's still a lot of research to be done. There were several historical turning points in the field of NLP. Maybe the ones you've witnessed were, maybe you've witnessed the LLM one, but prior to that there was also the deep learning wave and the statistical NLP wave and the rule-based NLP wave. So the next wave will come, we just don't know when, but it will come. And whenever it happens, people just really narrow down on these few architectures, or maybe this one architecture, and try to get as much out of it as possible before moving on to the next one. But that doesn't mean that there aren't alternatives. And these LLMs, they've caused major disruptions to the field because NLP is used by many lay people. Also, there are substantially more resources that are required to do NLP methodology research. So in academia, people can't really train LLMs from scratch. Some people do. There are some country-level initiatives, including in Denmark, to train a Danish LLM. So when people pool their resources, it can still be done. But then they're usually more development efforts than real methodology research efforts. So most of the research you see in natural language processing these days are about probing language models, what do they know, what do they not know, or doing really small-scale experiments. But there's very little methodology research these days. And the core LLM developments are really been done by industry. And despite how costly it is to release LLMs, more and more LLMs are being released, and it feels like hardly a week goes by where there aren't some kind of LLM news still. Also, the LLMs being more easily accessible means that LLMs are used as methods in other fields, in the social sciences and humanities. And yeah, what else do I have? Okay, there's less research on task-specific models and more research on general purpose models. Yeah, and as I said, many research questions seem answered, and traditional tasks no longer seem relevant, but I would argue that they still are, and there's still a lot that can be done. Then yeah, another thing that's still ongoing is the AI arms race, which I mentioned, of more and more LLMs being released. And they're getting bigger and bigger. You have the size. No, I think this is the performance you have here. And this is the picture if you look at the language models, but then the arms race can also be seen at a country scale, and there are some countries which emerge as winners these days, which invest a lot into language models. There's the US at the top, closely followed by China, and then especially smaller countries like Denmark, and I've added Estonia at the bottom, are not, they're smaller, so they cannot invest as heavily in LLMs, of course, but some smaller countries, like you can see, Singapore is third, so they do invest very, very heavily in it. But there's also this competition between companies of who can gain this, who can profit from this. And if you look underneath the hood, I already mentioned something about this earlier, is that the current recipe for improving the performance of LLMs is still that you need to increase the model size, you need to increase the amount of training data, and you need to increase the amount of compute you throw at these models. But we're reaching this ceiling of what can be achieved with that. What's also important is really increasing the quality of training data, and also architecture innovations. For example, what's already being done are sparse models. But yeah, there are several buts. So the one but is that larger language models do not always perform better. This is quite interesting. And also the market for smaller language models is increasing as people want to spend less money on using them and also want to be able to deploy them in settings where they don't have so much space. Yeah, there are many applications where LLMs are not the best tool for the job. Think about calculations. Maybe you just need a calculator. Then, yeah, more architecture research is definitely needed, but at the moment there is very little appetite for doing that because so much money has been invested in LLMs that they're too big to fail in many ways, and also revisiting the fundamentals is quite costly if it's the fundamentals of LLMs. And if it's the fundamentals of NLP as such, it's just that there isn't a lot of interest. But people are working on that, a few people, and at some point I can promise you the next revolution will come. We'll see when it happens. But yeah, so just to say the recent developments, this is was released, GPT-5 was available for public release from Thursday onwards last week, I think. And there is one interesting thing about GPT-5 that I wanted to mention, which is that it has this switch where it decides what kind of model to use, if it uses a bigger or a smaller model. And this is the first, as far as I'm aware, first commercial LLM to introduce this kind of switch. And this signals that there is some kind of shift that might be coming, which is maybe a smaller shift, but an acknowledgement that you don't always just want to have one model to do the job, but you might want to be able to switch between different kinds of models. It means that you don't always need a bigger model, but also maybe that, yeah, a bigger model doesn't always perform best. So one thing that could be happening in the more near-term future is that we see more LLM releases that have these kinds of switches where you maybe just don't have two models, but maybe even more models that it switches between, depending on the kind of question. And that's really represents a shift away from general AI and one model for everything to maybe this wasn't the best paradigm after all, maybe we do want to have different models for different tasks. Yeah, and the models perform a lot better on just random inputs. So from here, this is from the OpenAI website, so take this with a grain of salt. O3 had a 22% rate of just having at least one error per input, and apparently GPT-5 gets it down to 4.8% with the best model they have. So this is then quite an improvement. Okay, and as I said, there are many open topics still to be researched. And this is just to borrow a quote from Chris Manning saying there's nothing but blue skies within NLP. This is another lecture I can recommend if you want to watch it, to really illustrate that NLP isn't done as a field. There's much more to be done. Another thing is that a quote by Karen Spark-Jones saying that those who had been around for a while can see old ideas reappearing in new guises, but the new costumes are better made, of better materials, as well as more becoming. So research is not so much going around in circles as ascending in a spiral. And this is also what I mean by saying that there was this idea that there should be one model for everything, but now we're sort of maybe starting to go back to maybe we should have different models for different tasks, and then with this new thing of having a switch that can decide which one to use, right? But I can, yeah, there are many more examples of this. So there are many different things you can still work on. Of course, there's factuality issues, which I mentioned, instability to prompt variations, evaluation, interpretability, bias and fairness, cross-cultural aspects, multimodal aspects. Then something I haven't so much talked about, but is the carbon footprint, the massive carbon footprint of training and deploying models. So smaller model development is something that can be done, or more efficient model training or decoding also. And many different applications and possibility for interdisciplinary research. And here are also some pointers. I don't know if you already have my slides, but you will surely get them afterwards, where you can look at some more examples of what one can work on within the area to get some inspiration. There are different kinds of applied research areas too, for example, child language acquisition, NLP in education, NLP in healthcare, and so forth. Okay, so this was it then. I would like to also thank my lab for all of the excellent research that they have done. You can have a look at our recent publications too. And I also want to thank you for coming today and listening to me. And now I hope you still have some questions. Yes. So.